Hi guys, yeah, once again welcome back to the thin class of operating system concepts. And today in this last session, I will just try to discuss about the deadlock, and this will be the last concept that I will discuss in operating system. And after this, I will discuss more about the programming concepts of operating system in the next sessions. Okay, so let's begin. Okay, before beginning, then I just like to give you the uh, traditional humor concept. Okay, so in this traditional humor concept, today the thought of the today is like when I see, something like, when I see a hot girl, okay, like I take like 2 seconds, okay, to plan our future together. So see, this was the thought of the today. Now let's begin the session now. Okay, so what is a deadlock problem? A deadlock problem is a situation when this kind of situation occurred in our previous lectures so many times, right? Like while we are synchronizing the process or trying to synchronize among the two or more than process to more than two process, like because a process was, like for example, while using this semaphore, while you are waiting for a particular process which is acquired by another process, and this another process is also waiting for another process which is acquired by this particular process. So a situation in which the set of block processes each holding a resources and waiting to acquire resources held by another process in the set is called a deadlock problem. You can clearly see in this example and about like the deadlock situation that was occurred here in a traffic situation. Like this is a one-way road in which two cars are in a deadlock situation, whereas some other waiting cars are in the starvation situation, so that neither of one car is like pulling it back and letting all the other process pass through, right? So the starvation is occurring here. So this kind of situation is often quoted as deadlock problem. So how can a deadlock arise then? It can arise in 4 conditions. Okay, and these 4 conditions are either mutual exclusion, like before we perform mutual exclusions to synchronize among many processes, right? So only one process at a time can use the resource. So deadlock can occur in mutual exclusion procedure. Okay, mutual exclusion situation, because in mutual exclusion only one process at a time can use the resources, whereas all the other processes must wait for this process to complete the task, right? So whereas also deadlock can arise in hold and wait situation. A process holds at least one resources and is still waiting for another additional resources, okay, held by other processes. In this situation, the process will be still waiting on to acquire all the other additional resources, whereas it is holding the resources that is being waited by another other processes. Okay, so in this situation also the deadlock arises, whereas also in no preemption situation deadlock arises, like if there is no time slice for the particular process to complete the task. Okay, so the resources will only voluntarily like release the process only after completing the task. Then in this situation also the deadlock can arise where there is no preemption. Even in circular wait, like for example, if a process 1 is waiting for the resources which is held by process 2, and process 2 is holding resources which is held by process 3, and so on. So there is some kind of chain reaction circular reaction, and this is called circular rate. So what are the resource allocation graph then? So if you go and check out the graph to show this kind of situation, okay, of resource allocation, it's called resource allocation graph, like who is waiting for which kind of resources and who is acquiring what kind of resources. So this kind of information is provided in a resource allocation graph. Now for the index, you can see how the process is denoted by this symbol, whereas resource type with 4 instances are denoted by this, respectively. Process I, which requests the instance of P of Rj, is denoted by this symbol, and whereas process J is holding in an instance of Rj is denoted by this particular symbol. Now if you check out the graph, this is a resource allocation graph with a deadlock. Here the deadlock is occurred because you can check out this particular resource is holding only one instance, and process 2 is waiting for this resource, okay, that is acquired by this R1 block, okay. And you can see this process 2 is waiting for the resource from R2, and whereas also it is holding the resource for actually this is holding the resources for R3, and this is waiting for resources from R2, okay. So in similar situation, there are also process 3 is waiting for resources from R3 and acquiring the resources of R2. So there is some kind of chain reaction there, right? And similarly, so deadlock is occurred here. Similarly, here in this situation, the allocation graph, the resource allocation graph has a cycle, but there is no deadlock because there are the R1 block is allocating or has 2 or more instances. It has 2 instances. Even R2 block has 2 instances. So that means process 1 is waiting for resources from R2, whereas it is holding the resources of R1, and process 2 is waiting for resources from R1, whereas there is no chain reaction here. Circular block here, okay. Whereas you can see out process 3 is holding the resources of R2, whereas it is acquiring the resources of R1. So, and here the similar situation, the R2 block has 2 instances and R2 is holding the resources of P4, okay. So here there was no deadlock, right? And the general rule is that you have to understand is, if there is no cycle, then there is no deadlock. Okay, having no cycle has no deadlock, means no deadlock. So how do we perform the deadlock prevention then? So the occurrence of deadlock were due to these 4 conditions, right? So we can also prevent the deadlock by avoiding this kind of 4 conditions. So in mutual exclusion, we will not use this mutual exclusion in case of shareable resources, so we prevent the deadlock situation. And mostly it's used for non-shareable resources, whereas for hold and wait, we have to use 2 kind of phenomena. That is we request all the resources first, then only we release the resources, okay, or we release all the resources before requesting. So this kind of activities is performed in case of hold and wait situation, so that to prevent like you are holding one and waiting for another, right? So this doesn't happen, like either you request all or you hold all, right? And you release all before requesting. So in case of no preemption, we just try to use the preemption. That means we decide or we define a time slice for each process to complete the task, and if the process is incapable of completing the task, then it goes to the ready list, or like the waiting list, not the ready list but the waiting list of the processes, and which will be accessed later. Whereas in case of circular wait, we try to, for all the processes we are waiting, we try to use the hierarchy. Okay, that means hierarchical like resource usage. That means like you, in this we try to use the processes like categorizing on the basis of the hierarchy. So whichever has the higher preference or category, these kind of processes are used first, just to prevent the deadlock. So this was all about the deadlock, and this was all about our last session of operating system concepts, and we will continue much more with the programming concepts later on in our upcoming new session. So till then, thank you for listening.